Welcome to CIT 262 System Design presentation on Chapter 1, Agile Continuous Delivery and the Three Ways. This is Group 5, Theron Dowdle, Sam Klein, and this is Marshall Evans. So first we're going to talk about the DevOps culture. I had never heard of it before, and I consider myself quite the technology freak. And you can see here some of the big names in technology that use this DevOps culture. This starting with a plan, then build, continuous integration, deploy it, operate it, get continuous feedback, and then just loop in this semi kind of Mobius strip that is going to continuously allow these cultures to not just develop, but also operate their software. So the first thing that we need to understand is it does work left to right. At first, you're going to develop something. You're going to start out ready, you're investigate what needs to be done, you're going to do it, and then it's going to get done as you develop it. When you put it into operations, you're already doing it, it gets done into operation, then your end user is going to use that technology, and then it's going to be delivered to them. Now, invariably, there's going to be a problem, and so at that point, you'll then loop back into the beginning. There's some very important principles in doing that. As it goes down the pipeline chain, you want to make your work visible so that other people can see what's going on and have understanding. You'll limit your work in progress. You're not going to take on a huge project with thousands of lines of code that you need to develop so that by the time you get done with it, you're going to have a problem. In doing that, you're going to reduce those batch sizes. You're going to reduce the number of handoffs from one person to the next, which is going to cause problems as you try and teach someone else what you've been doing. You're going to identify and elevate your constraints. So your bottlenecks. You are only going to be as fast as the slowest section of your development. So you're going to identify that bottleneck, and you're going to see what you need to do to eliminate it. And continuing with that, you'll eliminate that hardship. You'll eliminate any waste that you have in that development flow. So in order to do that, we're going to use Agile Continuous Delivery and what we call the three ways. Now, first of all, we're going to compare that with a manufacturing value stream because that's what it's essentially compared to. And I think back as to the first assembly line set up by Henry Ford, and he wanted to streamline that. Now, that streamlining was certain areas were good for manufacturing, and some of those areas will come over to technology, but not all of them. So the manufacturing value stream, it started when a customer made an order and you released some raw materials out onto the factory floor, and you continued with your value stream to try and get that end product to the customer. Now, a technology value stream is similar to that, but that process is what is required to convert a business hypothesis or an idea into a workable technology by your end user. So similar in area, but not everything is going to adapt over. So what we want to do is we want to focus on our deployment lead time. So let's say that customer makes this change and says, hey, our software would work better if we could do X, Y, and Z. That deployment lead time, that lead time ends when that value is actually implemented, and that customer can say, oh, I'm now going to do X, Y, and Z with that software. So like I said, to do that, the best way to do that, we're going to make it visible, reduce our batch sizes. We're not going to send those defects downstream, which is going to increase our bottlenecks. We're going to constantly optimize this kind of behavior so that we can decrease that lead time. So when we talk about lead time versus process time, our lead time is from when we get our work until it is passed to the next process. Now, this is what we want to eliminate, is this idle time. We essentially want our process time to equal our lead time to maximize our efficiency. So in our second way, we're going to do some fast and constant flow of feedback to improve what has been done. We're going to enable faster detection and recovery, so when we find a problem, we can get it fixed faster. We're going to get our quality back to the source. That means where the rubber meets the road, whoever is typing that code in, we want to increase our quality there because then we're not passing errors down the chain. And we're going to generate and embed knowledge so that we can constantly improve every single link in the chain. So in those principles of feedback, we're going to work safely within our complex systems. There were some stories about 3 Mile Island, about the U.S. naval reactor, and how those were incredibly complex systems, that those nuclear systems and those nuclear instrumentation safeguards could be incredibly complex. And what we do is we want to work safely within that, whether it's a simple bit of code to make a website more efficient, or whether we're actually working on something like a nuclear reactor. So what we want to do is we want to see problems as they occur so that we don't get problems continuing to go down that chain. That's going to be our advantage of the small batches that we have. If you have one little problem, you're going to make sure that that little problem is taken care of within a little feedback loop. So when we do have that problem, we're going to swarm all the resources that we have available to that. Now, in the Toyota system, when Toyota started to implement some of these technology principles over to their manufacturing, they had what they call an andon cord. And anybody that worked on the line, or the managers, had that andon cord. If they recognized any kind of a problem, such as a defect or whatever the case may be, they would pull that andon cord and they would solve that problem then and there. And the longer that that production line was shut down, the more people would actually move in on that problem and make suggestions on how to solve it. It was very, very interesting. It was suggested in the book that when the number of andon cord pulls dropped, that what the plant managers would do is they would decrease tolerances. They would make things more fine and try and get things more dialed in and more efficient how they wanted to, so that that would actually increase the number of cord pulls in order to enable more learnings and improvements and detect ever weaker failure signals, as quoted in the book. So shutting down production is not always a good thing. It's kind of a hard lesson to learn that makes your process more efficient and your tolerances tighter. So we keep pushing that quality closer to the source. As we have problems in quality, the more that we can push that up to change and the chain and solve that problem where it begins, that is going to increase your quality the most. In large bureaucratic institutions, the variance between who should do something and who should actually do something is too large. That comes to mind with the problem that they had in the U.S. government's Human Resources Division, when they had a huge hack in that and they stole a lot of employee data. The difference between who could actually solve that problem and who actually could solve that problem, who should do it and who could do it, was incredibly large, and it took so much time and literally acts of Congress to be able to solve the problem. Eventually, what we want to do is enable those optimizing downstream work centers. You want to really take care of the person that you're handing off your bit of code to. If you give them a problem, they're not going to instantly recognize it. The most important person that you need to think about is the next person downstream that is going to be implementing your code. So the third way is we want to actively seek that information, share our responsibilities, bridge between those teams and reward that, and welcome any new ideas that are put forth. So to be able to do that, we want to enable organization learning and a safety culture. We do not name, blame, and shame. That's not going to solve any problems. What we want to do is have a generative area in which people can work, where we don't name people for their problems, we don't blame them for the things they do, and we don't make them feel bad for causing a problem. What we want to do is make them feel safe and give them an environment of education where they can learn. So we want to institutionalize the improvement of daily work. More important than daily work is the improvement of daily work. Now, a lot of times, and I'm going to be bluntly honest with you, as I started to read this book, it was a little hard for me to get into it. It seemed rather dry. It was hard to think of practical applications. But the more that I read about it and the more I think about it, that's actually the case. In the place where I work, we have a motto where we just want to be 1% better tomorrow than we were today. And we just want to do that constant improvement. That is going to help transform us as we continue on. We're going to transform those local discoveries into global improvements. So the tacit knowledge that we have that's going to be difficult, the tacit knowledge that we have is going to be that's kind of in our brains and that we do on autopilot. What we want to do is we want to convert that into explicit knowledge that we can share with other people. When doing so, we'll inject that resilience into patterns of our daily work. We'll introduce tension to elevate performance. We will drive each other. We'll ask each other to be better, and we'll pull that and-on cord if we need to. And then our leaders are going to reinforce a learning culture. Leaders are not necessarily leaders because they make the best decision. The leader's role is to create those conditions so that their team can discover their greatness in their daily work. No matter what you do, your daily work can sometimes get a little bit rote and a little bit boring. But what that leader's role is to do is to encourage you and help you to be the best that you can absolutely be. So in conclusion, we've done a compare and contrast from manufacturing to technology. We want to discover how we can improve flow, how we can create feedback in that flow, and then we can create cultures that value learning, enable trust, we experiment and share, and then we're going to continually do that as we develop and put things into operations for our customers. Thanks for your time.